And welcome back to Microsoft Virtualization with Hyper-V and System Center. Corey Hines, Simon Perriman, back for the last stretch of our two-day jumpstart.
Getting there, yep.
So this particular module that we're going to start with this afternoon is creating and managing VMs with VMM. So what we've done all morning is lay the foundation for Virtual Machine Manager and all the assorted objects, types of objects you can create, how you connect up the infrastructure, your hosts, your clusters, file servers, storage, networking, switches, all that stuff, leading up to the point where, hey, we're going to go start creating VMs now and looking at the different methods that you can use to create VMs. Things like, just straight VM creation through using intelligent placement, but also cloning and converting. So how we take, VMs, do clones to make copies, and then convert VMs from other types and formats, such as from, VMDX files, for example.
That's right, yep.
So without further ado, let's jump in.
All right, so our first lesson, pretty straightforward here. We're going to go deploy some VMs. We're going to go do a standard VM deployment. We are going to do a VM deployment using PowerShell. And then we're going to go create a VM using actually one of the templates that we've just built. So created virtual machines in VMM. You're going to see this interface shortly. As you go through the wizard, it's going to be pretty similar to the traditional Hyper-V wizard if you haven't pre-configured anything. If you do use templates, the things that we've just built, you'll be able to select the templates as you go through this process. But ultimately, you're going to get a lot of the similar configuration options as you really kind of build that actual virtual machine itself. Where VMM takes you to the next step is managing placement of that VM. So kind of part one is create that VM. Part two is where are we going to make it run? What's the appropriate host? Does that host have the appropriate storage connections, network connections, virtual network connections? And then does it have the same type of capability profile, such as all VMM? Which cloud should it run in? So you're really going to see this as two parts. Part one, create the VM. Part two, optimize the placement. As we go through and look at placement for VM, you're going to start to see this wizard that's called our Intelligent Placement Wizard. Intelligent Placement, or IP, essentially gives you a star rating system for which host is the best host to run this on.
So, all the stuff we talked about this morning, right, through using networks, using, host reserves, the templates that assign permissions, it all accumulates into this right here. Like I said, at the end of the day, when you go to deploy a VM, all that work you've done to lay down that foundation, setting up your virtual network, setting up your logical networks, associating network adapter cards, associating RAM values, the hardware profiles, the intelligent placement takes all that into consideration when it provides a recommendation for the host that should contain your VM. And you can ignore it, quite frankly. It's a recommendation, but that's ultimately where this all kind of bubbles up to the surface in, everything from performance to capability.
Absolutely. And what you're going to notice as we go through these exercises is if you're not following one of these best practices, it will actually explain what the problem is, why a particular host was not rated for placement. A good example might be that you've said that this particular VM has to be highly available, and you don't have any clusters available. You only have standalone hosts. In that case, you're going to get that 0 stars, not an appropriate host, but we're still going to ultimately let you deploy it if you need.
Where that becomes pretty common as well is when you deal with the network objects. If you've not associated any network interfaces on a host with a particular logical network, and the VM requires the logical network, you're going, well, why can't I put it on host 3? No network adapters on this logical network. Oh, go fix that, test it again, you should be good to go.
Yep, so really the guidance is kind of one of the added bonuses here, making sure that you really are going to follow best practices and the VM will be functional after it's deployed. And so this will take kind of a lot of the configuration considerations out of this for you. Using the star system, you kind of get some good guidance as to where you want to place your VMs. Now let's go ahead and go to our demo. So here we are back inside Virtual Machine Manager on System Center 2012 R2. And we're now going to go over to our VMs and Services workspace. Now we've already got our virtual network built. We've got our host, but we don't have any VMs running on this host. So again, as we kind of look at the different hosts we have SCVMM01 as a standalone host, and then our cluster Hyper-V. So let's go ahead and create a new virtual machine. Now during this process, when we kick it off, we have two options. Creating a brand new virtual machine with a blank VHD. And if we kind of go down that path, you're going to get kind of the same configuration options you have with Hyper-V.
The generation is there, for example?
Yep. Generation, all those profiles. But since we're really focused on using templates, building in that standardization, we're going to go ahead and build a VM from a template. Now, for this first VM we're going to use, we're just going to kind of go through these steps as a proof of concept. So we're not actually going to go and create a full VM template. So we see the full completed VMs up here. We're just going to go ahead and select a brand new VHD disk. So in this case, let's go ahead and select our file server VHD. We're going to say that this VM is going to go serve as a file server. Click Next. So we'll call this VM 01. Again, generation 1, generation 2. Click Next. And then, since this is a brand new VM, none of these profiles are pre-configured for us, but we could go and add them still. So even if it wanted to be a unique VM, we could still go and use one of those other profiles we selected. Now, we can, for the most part, keep the default settings here. But what is different in VMM than what you get using basic Hyper-V Manager is, first of all, the compatibility profile. What type of host should these run on? And since this is going to be a Hyper-V virtual machine, and we're using a VHDX file type, we need to make sure that we place it on a Hyper-V host.
So you could have other host profiles that included specific requirements for the host, right?
That's
so,
right. Maybe you need Hyper-V high speed, something like that.
Something requiring 10, or with a RemoteFX video card, or with a fiber channel adapter. These three built-in profiles are basically platform.
Exactly.
They just say, hey, it's enough to identify the type of platform, but you can take that to another level of detail and go very specific types of hardware on a platform.
That's right. And then the traditional configuration options. Now, for this VM, you know what? Let's make this highly available. And we're also going to go and create this as part of an availability set. I'll cover that in a second. So we'll go and say this is a high priority, high available virtual machine. So let's spend a minute talking about availability sets. We covered this yesterday as we looked at it through Failover Cluster Manager. And within Failover Cluster Manager, this was exposed as what we call an anti-affinity group. Specifically, it used a property of the cluster called anti-affinity class name. Now, very honestly, it's a little tough to configure these private properties, this anti-affinity class name. It's done through PowerShell, so VMM exposes this through the GUI and creates this concept called availability sets. And essentially, if you place two VMs in the same availability set, we're going to use anti-affinity and purposely try to distribute them across different hosts.
You like saying anti-affinity, don't you?
Anti-affinity.
You've said it
rolls off the tongue.
5 times in the last.
Okay, everyone take a shot when I say anti-affinity. So what we're now doing is, with this availability set, and again, some good examples that you'd use this for, identical infrastructure servers, right? You have 2 domain controllers, have them run on separate hosts. A guest cluster, have the different guest cluster nodes run across different hosts. So we're now going to go create our availability set, and we're going to call this our file availability. So this is going to be a file server. Click OK. And right now, this is the only VM that's part of this availability set. So until we have a second VM that's going to be part of this, this property won't really impact anything. So we've configured our hardware settings. We now go and select our destination settings. So we could go store this virtual machine offline inside our library, but we want to go and place this actually on a host. So let's go place this in one of the hosts in the Contoso host group. Click Next, and this is where we're going to start to get our star generation. Okay, so here's a question for you guys. Why do these 2 hosts have 4-star rating, yet this other host has a 0-star rating? Why do these 2 cluster nodes have a 4-star rating and the standalone host does not? Well, let's take a look at the rating explanation tab.
I know.
Okay, you got it. Go for it, Corey.
Oh, I can't actually read the screen. I was just playing into your thing. So
I
think I know.
Let's zoom in a little here and we'll see why. So as we zoom in, the rating explanation says this virtual machine is configured to be highly available, but this particular host is not part of a cluster. Now again, we could go ahead and proceed and click Next. It's not going to block us, but we're kind of violating one of the goals for this particular VM. Now if I click on Node 1 or Node 2 in the cluster, get a nice rating, everything looks good, it's a Hyper-V host, I'm up to date. Now there's also an option on the top here for expected utilization. This is a feature that isn't used particularly often, but it kind of helps you do some prediction and some planning And what you can basically say is, how much I/O is this particular VM going to be using? Based on your expectation, right? You know, this is a prediction. It's not an actual test. So is it going to take up 20% of the CPU? How much disk space? How much disk IOPS per second? What type of network utilization? So we're essentially creating a simulated VM load. Once we would do that, it could go and actually change those different settings. So let's say, for example, node 1 had, well, that's not a good case for a cluster because they use shared storage. Let's say, for example, node 1 had some throttled bandwidth on it, node 2 didn't. Well, if this particular VM used a lot of bandwidth, we then might actually recommend one node or the other node. So this could even be granular based on this anticipated load. And this rating system will dynamically update. So an example test question might be, how can you use Virtual Machine Manager to predict the load of a VM before placement? And you do that using this expected utilization button. And let's go ahead and we'll select DPM01 as our cluster node. Click Next. And go configure some additional settings here. So where do I want to go store this VM? Well, since this is a cluster, and I have some CSV disks, I want to go ahead and actually put this on one of my cluster shared volume disks. This is, again, the distributed access file system for Hyper-V. So I got to change the path to cluster shared volumes. So even though our default path was one thing, now that we've made it a cluster, we want to make sure that we are using the cluster path as well. Now, if I had some additional networking or fiber channel options, I could configure these here. Click Next. Now, the next thing it's going to ask us is about what virtual switches should this VM connect to. So this VM, as we defined it back in our hardware profile, had one virtual network adapter. What we can do is we could go create switches, add it to port classifications, add it to VLAN classifications if these were configured. But you know what? We're not going to go and connect this to the network quite yet. Final thing we can do here are the action properties for the virtual machine which is running. So the first choice here is, what is the action to perform when a virtual machine starts? We have three different options here. Always start the VM, don't start it, or turn it on if it was running before the crash. Now, Corey, do you have recommendations as far as if you're doing reboots? What's kind of a good best practice for the automatic restart operation?
Well, it depends on how important the VM is. So, like yesterday, we talked about this notion of doing, in a cluster, high, VMs that are set to high, medium, and low in terms of priority. If you choose to restart the VM, and you know it can, I guess here's what I kind of do. If you can feel like you can pull the power cord and the VM will come back up in a healthy state, then you're probably okay to do this. If the VM's critical and you want it to reboot and it's okay rebooting on its own, then you can let it go ahead and reboot. But at the end of the day, it depends on what's happening in the VM, how well that VM will survive an actual reboot, as to whether you want it to just auto restart. Most of the production VMs that we put in, we don't necessarily want them to auto restart in the event of a total failure, because we want to be able to go in and make sure that they're coming up healthy, with the exception of things like domain controllers that we know we need to bring up. But for non-super critical roles, just try and have those come up so we can watch and make sure everything, check service, make sure everything starts properly.
So I think your best practice is it depends, right? What is the application?
Yeah.
How does it need to start? What other dependencies are there in the infrastructure?
Yeah, the best practice is think about it and make a smart decision.
Okay, good best practice. So second option that we can see under configuration is a delay timer. How long do we want to delay the startup? So this could be used in a couple of cases. First of all, this could be used to help prevent startup storms. The system is booting, starting up too many VMs at once. Second way this can be used is for dependencies. So let's say you have a series of 3 VMs that need to come up in a certain order. Well, you could configure the first one to have a 15-second delay, the next one a 30-second delay, 1-minute delay, something like that. So you can kind of stagger when each of them are going to start up. Now, the other option we have here is what happens when the virtual server stops. And this is basically saying, if you have a graceful shutdown, as opposed to a hard crash where someone pulls the power, if you have a graceful shutdown, what's the behavior we're going to take here? Do we want to save the running state of the VM to a disk? Do we want to turn off the VM, which is basically equivalent to pulling out the power, it just kills it? Or do we want to gracefully shut down the VM? So you've got these 3 different options here. this case, we'll go with the save state. And then, which is the OS that's going to be running inside that VM data center? Now, we also have a feature here called performance and resource optimization. We're going to be talking about that a little later when we look at some of our integration between Operations Manager and VMM.
Now, you pick the operating system there. At the end of the day, what is that doing when you select that operating system?
So basically what we're doing when we're specifying the operating system, we're going to go and inject the integration components for that appropriate version of Virtual Machine Manager. Oh, sorry, that appropriate version for the guest operating system. As a refresher, the integration components are what makes the VM know that it's a VM. This includes things such as the ability to start the VM, stop it, pause it, to send commands from the physical server up to the VM, and to do some some security configurations if you're going to cluster it and do that VM health monitoring inside. Again, equivalent to VM tools as far as those pieces. And basically the reason why we selected here is each operating system, not each, but a lot of the operating systems have different integration components, and you can see that we even have all the Linux distributions listed as well. And so it's just going to make sure that we install the correct integration components on those VMs. All right, we can view the script, and this is actually where we're going to go and do some scripting as well. So take a quick look at this create script here.
All right, so what this script is doing, I was looking at some questions, so I didn't quite catch what you were doing. So you're catching me a little bit off guard right here. So I would need to take a look at it.
So basically what this script here is doing is we're going to go ahead and first create our virtual SCSI adapters, so our network, our DVD drives, virtual non-SCSI adapters, so our IDE adapters, COM ports, floppy drives, CPU, capability profiles, and then basically define that into a hardware profile.
So, I mean, this whole process right here is what was created when you ran that create VM wizard, correct?
Correct. Now, this hasn't actually executed until I hit create the first time, but it kind of tells me, well, what is going to run.
Right, and so you can actually go through this and see this is, the entire process of making a VM. Now, there's a lot of stuff in here because you specified, a fairly large number of properties when you went through and configured this thing and pulled them all from the template. So certainly a create VM PowerShell command, even in Virtual Machine Manager, doesn't need to be this complicated.
Absolutely.
But if but what you've got here is something that you can very easily, if you know PowerShell, go through and automate to a great degree.
Let's do it.
A lot of people, if you just go back to the script for a second, I've been asking about these ID values that are kind of hiding in there. And the importance of them, those are actually used for the job tracking. And so the scripting engine injects those in. You don't need to necessarily inject those if you write your own
Correct.
scripts. It's
an optional parameter.
Yeah. And they're used when VMM does run through the wizards. This is how it does the replay component, because it creates this job. It's got an ID value, so when you want to retry a job, it uses the ID to make sure it retries the exact same job again.
Yeah, essentially it's a tag that allows it to group these different activities together so that it knows this is a collection of activities. We want to kind of work these through as a group.
Yeah, but if you're going to write your own scripts, you don't got to worry about it.
Absolutely. So let's go ahead and we're going to go and save this PowerShell script into our library so that we can access it later. So I'm going to go to DC01, VM share. Let's go to DC01. It doesn't really matter. We'll just put it back in our VMM library. That's fine. And we're going to make sure we save this as a PowerShell script. So that's important. And we're going to call this vmcreate.ps1. Save it as our PowerShell script.
So what you're doing is just changing it to all files to actually put the .ps1 extension. If you leave it at the default, it'll be .ps1.txt, which is not recognized as an executable type file, so that run action you're going to show won't turn up. That's
correct. Yep. So we've now saved the script, and in a minute we're going to go and create a second VM using that script. So let's go ahead. We have an option to start the VM after deploying it. That is disabled by default. It's an assumption that other VMs are going to be created. Other configuration steps will be needed. So we click Create. We're creating our VM.
So just click on the Details tab. And this is where you can see all the individual steps that are happening, and that's where the ID value ties all those together.
That's right, yep. So we see everything be created here. And what we're now going to do is actually go into our library, take a look at that script we've just created. 1 second. Let's just go take a look at our actual VMs now, before we do that. So here we go. Here's the newly created VM. Currently in the stop state. We can see that it's part of the file availability set. Host CPU average, everything else. Again, it's turned off. So if I go actually look at the cluster, we can see everything broken down. It's currently running on DPM-01. Back to our library, let's start to take a look at these PowerShell scripts here. So now that I've gone and created a new object in this library, I'm just going to refresh it, make sure that we go and collect it. By default, I believe the refresh is every 5 minutes. So if you've gone and copied something into the library, it could take just a couple minutes for it to appear.
The library, I think, is actually an hour.
Is it an hour?
I think it's an hour. At one point, in one version, it was an hour. At one point, it was an hour. I don't think I've actually looked at that setting in this version.
Okay.
But
Well, you know what? We have an open question. So for our Q&A people that are helping us out, if you could do a quick search on that, what is the frequency that the library
I think
refreshes?
it's configurable in the settings, but we don't need to go there.
So what we now have here is we force the refresh so it appears immediately. And take a look at my VM library, and here's the script. So we can see that this is now a library object that we can manage. So I can say view the file, pulls it out, open the file location, and I even have the option to rerun the script. Now what I'm going to do here is take this script, do some edits inside PowerShell ISC. I just click edit here, that should open ISC. And we're going to go replace some variables in it. Now, the very first thing that I'm going to do is just set my execution policy. And basically, hey Corey, can you actually cover what does setting the execution policy do?
So by default, PowerShell assumes that everything is bad. So all scripts are evil and they're designed to hurt you and they're going to break everything. So the result of that is it will not let you run any script other than something you've written on that machine. So if you want to start running scripts that are, for example, on file shares, which are possibly places where bad things could be, it says no. And so the execution policy is a way of controlling the level of, the requirements for a particular script to be able to run. So as an example, if you set it to local only, it's only local scripts. If you set it to remote, it'll run remote scripts. You can also require that it be a signed script. So the script's actually signed with an Authenticode certificate to verify that it hasn't been modified or altered. So you've got a couple of different levels of execution policy that you can set. For most guys that do this, they set it unrestricted because they go, you know what, I trust my scripts.
I trust myself, yep. So in this case, we're just going to go ahead, set this as unrestricted, make sure that we eliminate any variables there. And then to go edit the script, PowerShell has this nice editing function called replace in script. Okay, you guys know it as just replace. But what we're going to do here is say we want to find VM1. And now we're going to start calling it VM2. And so this will go through the whole script. And it will replace every instance of VM01 with VM02. Now this will make sure that we have a unique name in the script. Okay, we've done that. Click close. We'll save the script again. And let's execute it. Run the script. We will wait about 30 seconds and we'll get the output. Everything's being created down here. Script is done. So now let's go back inside VMM, take a look at our VMs and services, and look at that. Our second virtual machine is now being created from that exact same script.
Now, if you wanted to do, 5 VMs in that script, do you know how you would go about doing that, or is that?
Well, I'm not a great scripting guy, so I would go and edit that variable 5 times and hit run 5 times. How would you go pull in that batch file? I know you can inject batch files, nested loop in. How do you recommend we do it?
Well, so with PowerShell, it supports loops. So you could literally do what they call a for next loop within PowerShell, and just go on the top, literally go 1 dot 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 or 1 dot dot 5. You pipe that into a for next loop, and run the script, and it'll just make 5 VMs right in a row.
Awesome.
So that's the power of PowerShell. It's nothing to do with VMM. It's just the power of PowerShell. And if you're good with PowerShell, the world is your oyster.
Very nice. So we've now gone and showed you how we create a VM from a script. Let's go and show you a third way. Let's actually go and create a VM from the template that we built in our earlier exercise. And by the way, another feature within this as well is you can run the actual scripts directly from the library as well if you wanted to. So let's go into our VM template. Here's the VM template which we created in our last module. we can select this and we can say, create a VM. And what it's telling me here is some of the features that you've enabled are going to be part of a actual service on a particular VM. So not all the features are going to be added, but we're still going to let you continue. So in this case, we're going to call this VM03. Configure the hardware. Go configure our hardware settings. Operating system. We'll go and configure our operating system settings. You could actually see that we're using the template, of course. Destination, pick a host which it is going to run on. It's going to go take a look at our utilization, and it looks like it's going to flag some things. So let's investigate the challenges that we're seeing here. The number of processes on VM3, 32, is actually greater than the number of processes that our host has. Now remember, I'm just running these as VMs. These VMs have 2 processors, so it's actually going to prevent me from overcommitting an individual host. So this is one of the nice ways that you can ensure that as you're deploying something, you're not going to go get yourself into trouble. All right, that is our VM creation. Let's switch back to our demos, and now we're going to talk a little bit more about cloning and creating VMs.
This is just another way to go about creating VMs from a VM that you already have.
That's right.
Maybe you've deployed a file server and you just want 4 more file servers, and the file server you got deployed is the way you want it. So you can do these cloning operations. And then also, as part of this, we'll look at how we go about creating new virtual machines by importing other types of VMs from other platforms like VMware, for example.
That's right. Now, virtual machine cloning, one of the new features in Windows Server 2012 R2 Hyper-V is called live cloning. It allows you to actually take a clone of a running virtual machine with no downtime to that VM. So how do you use this? Well, we're thinking that people are going to be able to use this to do some troubleshooting of production systems. Now, a few considerations to keep in mind. If you take an exact clone of a running virtual machine, you're also cloning its domain name, its FQDN, and all of those unique identifying properties.
Those are really bad things to clone.
Exactly. So when we do the clone, what we want to make sure we do is with that clone, not actually start it up so we don't do any conflict. We want to go isolate it, and then we can start it up and troubleshooting. But we want to make sure it's not going to be on the exact same network as the real one, the original one.
Absolutely.
Now, what this means you can do as a troubleshooting mechanism is you could keep your slowly performing production system running, isolate a copy of that production system, figure out what you need to fix, take it down, add patches, whatever you need to do. Once you've figured out the fix, then you could go back to your original, go make the changes there. Alternatively, you could go and export the fixed one, keep it back onto your main network, but keep it offline, power down the bad one, power on the good one, assuming it has the same names and credentials, and clients can then start connecting to the good one. So you can kind of do almost like a hot swap, replace the good one with the bad one. So what happens with the VM cloning? Well, essentially, this is a way that you can do to do this rapid deployment as well as, isolate it and troubleshoot it. And it's going to make copies of all of those different components within a VM. So the VHD or VHDX file, the configuration files, which is the XML that defines the structure of that VM, and then the contents of its memory. Now, if you are using 2012 R2, the new version of Virtual Machine Manager, it supports live clones. If you're using 2012 RTM or Hyper-V 2012 RTM, you will not be able to do the live cloning. You have to actually take the VM offline. So some considerations around cloning. First of all, keep in mind that it contains those same unique identifiers, such as the security ID. And so if you are going to take a clone and redeploy it on the same network, same environment, you want to run syspert, or you want to go and manually change those variables. And then, of course, want to make sure that you have enough disk space around. Let's move and talk about converting a virtual machine as well. Now, what we want to do here, as we're looking at actually converting VMs, is going through and essentially copying, first of all, the VHD file, whatever their format is, to our VHD file. Secondly, the configuration information. So what's the physical layout in the XML? Map that back to our XML. Now, with our V2V migrations, there are a few limitations on this as well. One thing that it will do is, if you're going from VMware over to Hyper-V, It will remove VM tools. It will add the integration components. But the big catch with that is the boot drive. VMware virtual machines boot from SCSI. Hyper-V virtual machines boot from IDE.
Or SCSI,
Or SCSI.
depending on the generation.
Depending on the generation, good catch. So if you're converted to a Generation 1 virtual machine, you do need to go and switch it and change it from a SCSI boot to an IDE boot. If you're converting it to a Gen 2 virtual machine, you don't have to do that step. Now, Convergent supports all of our ESX versions here. So let's go over to our demo and actually take a look at this. So a little earlier in our modules, we went and added a offline virtual machine as a VMDK file. And if we go take a look at it in the library, so that's under VMware. This is essentially the offline file that we are going to copy, our VMware file.
So how did you get this? Is this the equivalent of like an export in VMware?
Yeah, it's basically it's basically an exported VM from VMware that goes and basically gives you a copy of the virtual machine and its associated file pieces that then get recomposed as the VM. And so you can see here we have the VMDK file. VMDK file is the equivalent of our VHD or our VHDX file. Now, what we've done to date is we just imported the full VM. But what if we wanted to just import that VMDK file? Let's take a look at that. Import a physical resource. And what this will do is it will take just that VMDK file and then make that as a reusable object in our templates. So I'm going to say add a resource. I'm going to go and navigate to my share, so DC01, VMware, and actually select this VMDK file. Where do we want to go and place it? Let's go place it in the VMware folder. View our script, import the resource, click import, and now this is going to go and import and make this VMDK file available for use. Now, very, very important clarification here. This does not convert the VMDK file. It is still a VMDK file. It does not make this able to run on Hyper-V. It is still a VMDK file. This means that this file can only be used when creating a new VMware virtual machine and placing it on an ESX host. But it's still an object in our library that we can manage. So as I go take a look at my VMware folder, we can now see this as a VMDK file type. So we've imported our VM, and we've also imported this VMDK file. Now, if I wanted to go and create a new virtual machine using this VMDK file, we'll call this VMware. We're going to go and hit an error because I just don't have any ESX servers that I can go and place this on. So this has to be placed on an ESX server because it's a VMDK file. Keep all the default settings. Try to place it on a host, and we're going to get error. Unsupported on this host virtualization software, unsupported, unsupported. And again, that's because we're trying to place a VMware VM on a Hyper-V system.
And it was primarily that compatibility profile that drove that decision-making process.
Yep, that's right. So let's now go and actually convert a VM. So we're going to take a full virtual machine, again, based on VMware virtual machine, and now we're going to go do a conversion. So this is actually going to go and convert the VMDK file to a VHD file, and then also copy the metadata from the configuration. Now, the way you need to remember that a virtual machine is composed is that it has an XML file that contains its configuration data. Again, the configuration data is things such as what's the name of the VM, what networks is it connected to, what is the memory, that type of thing. And a lot of those hardware components are standardized. So regardless of if you run a VM on VMware, you run a VM on Hyper-V, you still need to define the memory, the virtual networks, the boot, the disks, things like that. And so that is essentially what we are mapping. We're reading the VMware XML file, and we're remapping that to a Hyper-V XML file. That way Hyper-V can then understand how to use that VM. So under our Hyper-V manager, we're going to go to this option of convert a virtual machine. We then get asked to specify what is the original VM. And so here we go. We'll select this VM that's available in our library. We see it's an ESX server. Click Next. We then go get to specify a new name for it. So we'll kill this Windows Server 2012 HV for Hyper-V. Get to specify some hardware and some placement. I'm going to kick this down a little because my VMs are kind of small. Our simulated hosts are kind of small. Then it's going to go and search these hosts. Now, you're still going to see that, hey, none of these hosts are going to work. Why is that? Well, we will take a look here and take a look at this. So the disk is IDE. We have SCSI. This is going to cause a warning. Second thing we have is this particular host does not have the storage classification for this type of disk. Now, if we go back and we actually take a look at the disk, we'll have to do that back in the wizard. We'll see that it uses, we're using iSCSI disk, and this is not able to support iSCSI. Nevertheless, let's go ahead and add this anyway, since we're not going to go bring it online. We'll click Next, where we want to store it, keep our default location. Configure it to virtual networks if we wish. What actions do we want to take? Oh, let's turn on the VM. We can view our script, and we see a new SCV2V, a virtual to virtual conversion. Click Create, and this is going to go through this process of converting the VMDK to a VHD, and then extracting the VM tools, adding the integration components, and then remapping the metadata to ensure that this VM maps up with the same hardware profiles.
Now, from experience, once you've done this conversion, you bring the VM online, you need to take the time to go through to make sure everything works properly. Because what you've basically done is, taken the operating system, ripped all the hardware out of it, put a whole bunch of new hardware in and booted it up. And so there's, especially if you've got a lot of applications in there and things that, use the different types of virtual hardware, you just want to go through. Don't assume that everything's going to work perfectly because you've made such a drastic change. You just got to kind of make the time to go through the VM, make sure the VM is healthy. This isn't a magic button that makes everything work perfectly all the time. It will do the conversion, but there may be dependencies in the VM you've got to go resolve outside this process.
Absolutely. And actually, we have one of them highlighted here. So as we've done the V2V conversion, the conversion was successful. As we go zoom in here, take a look, it's saying, hey, we cannot locate the boot volume. Hence, there's going to be a problem when you try to start it up. And again, that's because of this IDE SCSI conflict. So I'll close my jobs window. I'll go down to this standalone host that I deployed it on. We can now see this VM that was created running on the host. And we have all this information that we injected. So we changed the memory, changed these other parameters, and then we would be able to go and start this VM once we went and reconfigured the operating system. So let's take a quick look at that. We can go down to our properties, and to general. We're going to now go and define our operating system. Go to our data center. We can add additional information, cost center, tags, things like that. And under our hardware configuration, we see that this is currently connected to IDE. So what we have to do here is create a new SCSI adapter, which is going to be our boot volume. We go select our Windows server. We'll go and move the channels, and then one of the final things we need to do is go configure it as a boot volume. And so that will be the end-to-end process. Now, I don't have the full VHD for that other version of Windows Server to go and inject that. As you may recall from the library, these sample VHDs that we have here, those are just small templates, not the actual full VHD. So I can't do that end-to-end conversion and go replace our OS on this. So that kind of summarizes how we do the conversion. I'm going to spend the next few minutes just kind of talking about some other third-party hypervisor management capabilities, going right from the top here. So kind of what can you do to VMware infrastructure and Citrix infrastructure? What can you not do? So going from the top here, we have a concept of clouds we'll be talking about actually in the next module, which is our collection of resources. We can manage Citrix and VMware using clouds. So you want to think of a cloud as a aggregated pool of resources containing all your storage, network, CPU, memory. Now, you want to break down clouds in a similar way that you can break down host groups. And so you may have a cloud just for your ESX servers. So we do support this concept of clouds here as well. With VM networks, we can go and create VM networks on our Citrix and our VMware infrastructure. Go connect those VMs to that, have them communicate across that ESXi infrastructure. We can provision storage to Citrix and VMware, so long as it supports that storage type and storage protocol. So, for example, VMware uses NFS, we use SMB. We wouldn't try to go and provision an SMB share over to VMware infrastructure. Wouldn't work correctly. And then as we look under our host management, we can go and add our different VMware infrastructure pieces to our various host groups. And that also includes our VMHA clusters, as well as our Xen clusters. So being able to manage both at the individual host level and at the full cluster level. As we look under Fabric, within infrastructure, we can use our same library servers to manage VMware and Citrix objects. You already saw us import an offline virtual machine and import a VMDK file. With our Pixie servers, I do not know, can we Pixie boot VMware or Citrix systems? Do they support Pixie boot network protocol?
No clue.
No clue. Okay, I have stumped myself on this one, so hopefully our Q&A team, they can help me out. Follow up on this one.
I'm sure
can we go Pixie boot to a VMware environment?
I'm sure someone out here knows the answer to that.
Now, within our update management, this is one area that does not support Citrix, does not support VMware. Microsoft updates function only on our Microsoft systems, so we have to apply those to Hyper-V hosts, other infrastructure servers running Windows. vCenter servers, this is where we'll actually see our collection of VMware servers. Now, under networking, we can take advantage of all of these different profile and networking capabilities on Xen, as well as VMware infrastructure. Storage, same concept. So long as the Citrix or the VMware infrastructure supports the various storage protocols, we can go add them. We can use providers. NFS file servers, again, not SMB.
So, by the way, there's a flood of, yes, you can Pixie boot VMware coming in on
Awesome.
chat.
Thank you, everybody. Yes, you can. Pixie boot VMware. Final thing we're going to browse through here is taking a look at our templates. These templates, both service templates, VMware templates, they can be applied to both Citrix and VMware infrastructures. We're going to look at services in our next module. Build our templates. They can be applied to VMware so long as they meet the hardware requirements. Again, VMDK is only going to run on VMware infrastructure, VHD, VHDX only on Hyper-V. Profiles can be used across all of these diverse clouds as well. And our library servers, again, can be used to manage these different clouds. Now, within our settings, this is an area where we haven't really explored much. Our settings here allow us to go and pre-configure some types of collection information. So how often do we refresh our library?
1 hour.
1 hour, there we go. Woohoo! Automatic library refresh. 5 points for Corey. How do we go and manage remote control? So what's the default port when we actually want to go and connect to one of the VMs in our infrastructure? What type of network settings are we going to use as we go and actually manage the VMM management server? Database connection to our SQL database. What is the name of our database? What's the name of the instance? We'll cover security shortly. Servicing windows basically allow you to predefine specific timings when you want to perform certain actions or avoid them. Configuration providers. These are essentially add-on modules that we can add, and we support VMware and Citrix configuration providers so long as they explicitly have a plugin for VMM. That's important as well. And so as an example, we have network load balancing built in. This is where, let's say you wanted to add an F5 load balancer. You could go add it as a configuration. And then console add-ins, again, if we want to go and actually add a component within the VMM console, we could go and add this component here. So you go import a console add-in. So this allows you to have features being built and developed by third parties. Well, that was And was a quick view of creating our VMs, managing VMs, as well as our third-party hypervisor management.
So our next module that we're going to move into here shortly deals with clouds with VMM. So now that we've done the fabric, we've done the storage, we've defined VMs, we now got to start taking an even higher look up and say, okay, how do we define logical groups of these resources that are limited to specific people, right? It's fine to, add SANs, but who's allowed to manage them? It's fine to create different types of VMs, but who's allowed to use them? And that's where the cloud element actually comes in. It's a partitioning of the capacity and the resources and limiting of permission so that you can only access those things you're allowed to access. So we'll be diving into that right after the break. I'll be coming back in about 10 minutes, so we'll see you guys then.
Thanks.